Hey guys, what we're going to talk about is being able to find the degree, the zeros, the y-intercept, the end behavior, and the multiplicity of the zeros, all from just the equation, okay? So I know yesterday in class we were all like, hey, what if we had a graph and we graphed it and we looked and we saw what the degree was, we saw what the zeros were, we saw what the y-intercept was, we saw what the end behavior was, and we saw, well, actually we have not talked about multiplicity. But now, all I want to talk about is being able to find these things without looking at a graph. Okay, so first off, the degree is pretty easy. The degree just comes from this idea that if you were to multiply all this out, what would be the highest power you end up with on an x? So in other words, remember, when you're multiplying, everything has to multiply to everything. So x times x times x times x, well, that would be x to the fourth, right? So then my highest power is going to be 4, so my degree is 4. Another way you can think about it is just how many x's are multiplying together, okay? The zeros. The easy way to get zeros is to understand that, hey, basically what you're trying to do is find where this thing is 0. So basically what you're trying to do is say, hey, 0 equals all this, okay? And what's cool about the number 0 is that if you multiply by 0, it all becomes 0. So in other words, if you could find a way to get this parenthesis to become 0, then all of this would become 0. If you found a way to get this parenthesis to become 0, all of this would become 0. This parenthesis becomes 0, all this becomes 0, and this parenthesis becomes 0, all this becomes 0. Okay? So basically all you're doing is you're just taking each guy and setting each one equal to 0. So then you would know that if x was negative 4, negative 4 plus 4 is 0. Okay? And that would make all that 0. So negative 4 is one of your zeros. And then you could do the same with the rest, and you'd get 2, negative 3, 4. Now, a lot of you say, oh, so I can just switch the signs. Yes and no. Okay? Yes, you can switch this sign, but if there was a coefficient in front of x, you would need to make sure you divided by it. Okay? Just don't forget that. All right, y-intercept. A y-intercept is just where I cross the y-axis. What do you know x is always when you cross the y-axis? What is x? 0. That's right. So basically you're plugging in a 0 for all of this, okay, and multiplying it all together. So you get 4 times negative 2, which is negative 8, negative 8 times 3, which is negative 24, negative 24 times 4, which is a number I don't know off the top of my head, but I know it's going to be positive. So turn my calculator on. 24 times 4. I know it's negative. Negative times negative is positive, so I went ahead and got rid of the negatives. 96. Okay. So the y-intercept is just the point 0, 96. Okay, end behavior. This is really the only new thing. I kind of went through fast through these things because this is all stuff you covered pretty extensively in Algebra 2. End behavior is literally what it sounds like. We are just looking at the ends of the graph. Okay? So, if you have a degree of 4, that's an even degree. If you have an even degree, your end behavior looks gonna so even. Okay, an even degree means that your end behavior is either going to be up and up or down and down. Okay? So, assuming that it's positive, the very front is positive, it's up and up. If you throw in a negative sign at the very front, it becomes down and down. So, in this case, the end behavior is going to be as x approaches negative infinity, okay, f of x approaches infinity, okay? Because it was an even degree, there was not a negative coefficient right here, so I can say that it must be up and up. So the ends of the graph looks up and up. I know it might squiggle in the middle, but all that matters is that it goes up and up. And we'll check this on the graph in a second, just to be sure. And then I can say, as x approaches infinity, so in other words, I'm saying when I look to the right side of the graph, I can say that the y value is going up again. Because again, it's an even degree, and there's a positive coefficient there. And so it goes up again. Okay? Now, multiplicity. multiplicity is somewhat new. Multiplicity has three things that you need to be aware of multiplicity. You can have a multiplicity of 1, you can have a multiplicity of 2, you can have a multiplicity of 3, or you can have multiplicities higher than that, but then they just follow these patterns. Okay, so if it was like a multiplicity of 4, it's going to follow this guy. Okay, if it was multiplicity of 5, it's going to follow this guy. All right. So if it has a multiplicity of 1, with a 0, okay, so these are zeros. Zeros have multiplicities. Okay, let me back up for a second. Let's say you had, I'm diverting from our example. I'm going to go back to that example in a second. Let's say you had something like x plus 2 squared, okay? And I was like, hey, find me the zeros, okay? So you were like, oh, okay. Well, the zero is simply a negative 2. Let me ask you a question. How many times is this negative 2, 0 actually happening? 2 times. That's right. So you would have a multiplicity of 2. Okay, since it's happening 2 times, you would have a multiplicity of 2. Okay? So then, what that means as far as graphically that means that at that 0 of 2, the graph either does one of two things. It either touches and bounces back up, like this, or it touches and bounces back down, like this. Okay? Let's say I added another 0 in. Okay? Let's say I had a 0 of x plus 1. Okay? So you'd be like, okay, well that 0 is a negative 1. Oh, I put this as a positive 2. It should have been over here. That's okay. Alright, how many times is this negative 1 happening? Well, only one time. It only has a degree of 1, so it's only happening one time. So it has a multiplicity of 1. So what does that mean graphically? Graphically, that means here at negative 1, we are just crossing through like a line. Okay? That's all that's going to happen, is we're just going to cross through like a line. And then, last but not least, what if we had a multiplicity of 3? Well, if we had a multiplicity of 3, such as, let's just say in the very front of this, ignore that, let's say in the very front of this, I just wrote x cubed. Okay, well that would give me a 0 of 0, but how many times is this 0, 0 happening? 3 times. So it would have a multiplicity of 3. Okay, which then means that it crosses through like this. If it has a multiplicity of 0, it goes up, it flattens, straightens out, and then shoots back up. So we could say it wiggles across it, okay? Comes up, wiggles across, shoots back up. All right? So that's what the multiplicities are, and that's what they look like, okay? The main focus for today is that you can tell me if it has multiplicity of 1, 2, 3, 4, you know, that idea. But I want you to start familiarizing yourselves with what the graph representation of different multiplicities will look like, because it'll become important later on. Okay? But again, for today, I just want you to be able to say, okay, multiplicity of 1, that crosses like a line. Multiplicity of 2, that either bounces up or bounces down. Multiplicity of 3, that squiggles across. So it could squiggle across like that. It could, of course, squiggle across like that. Okay? So just be aware that that's what they do graphically. But today, I just want you to be able to say, excuse me, I just want you to be able to say, okay, each one of these zeros, x plus 4, it only happened one time. Because there's an understood 1 right here, an understood 1 right here, an understood 1 right here, an understood 1 right here. So the multiplicity of all these are 1. So you could say the multiplicity is 1 for each 0. Now, if they had different multiplicities, I would expect you to list them out. Okay, like I did on that other example I did. All right. Okay, so that was assuming the degree was even. Okay, so let's just look at what happens if the degree is odd. Okay, well, if the degree is odd, the end behavior, one side goes one way and the other side goes the other way. So it's either going to look like this or it's going to look like this. It looks like this assuming it has a positive coefficient. It looks like this if it has a negative coefficient at the very, very front. Same thing here, but this is a positive coefficient, this is a negative coefficient. All right, so I know this video was a little convoluted. All right, so try to bring your questions back in class. Or, you know, if you're watching this over spring break, feel free to send me an email, and I'll try to make maybe another addendum to this video to try to explain things further. All right, thanks.